Hi, I'm Nitya, your tutor at Nityaz Academy. Let's learn applications of derivatives together, step by step. The derivative gives the slope at every point. At a peak or a valley, the curve momentarily levels off, so the slope is 0. Setting f prime equal to 0 finds these critical points. They're the candidates for maximums and minimums, the places where a function turns around. How do you tell a max from a minute? Look at the sign of the derivative on both sides. If the slope is positive, then turns negative, the function rose then fell, so that's a maximum. If it's negative, then turns positive, the function dipped then climbed, so that's a minimum. This is the first derivative test. Take f of x equals x squared minus 6, x plus 5. Its derivative is 2x minus 6. Set that to 0, x equals 3. Just before 3, the slope is negative. Just after it's positive, so the function dips and rises. That makes x equals 3 a minimum. The smallest value of this parabola lives there. Now an optimization problem. You have 40 meters of fence for a rectangle. The perimeter gives y equals 20 minus x. Area is x times y, which becomes 20x minus x squared. Differentiate. 20 minus 2x. Set to 0 and x equals 10, so y is 10 too. A 10 by 10 square gives the maximum area of 100 square meters. Let's recap. Set the derivative to 0 to find critical points. Check the sign of the slope on each side to classify them. Plus to minus is a maximum, minus to plus is a minimum. For word problems, write the quantity you want as a function, differentiate, set it to 0, and solve. That's how calculus finds the best answer. Great work! Keep practicing with Nitya at nityazacademy.com for free lessons, worked examples, and practice.